Have you ever looked up at the night sky and felt a sense of boundless, infinite space? It feels like our solar system is just a small island in a vast cosmic ocean. But what if I told you that our cosmic neighborhood might be enclosed, wrapped inside a colossal, invisible sphere, a frozen wall nearly 1.5 light-years across? This is the story of the Oort Cloud, the mysterious unseen boundary of our solar system. Now, the Oort Cloud isn't something you can spot with a telescope like you would a planet or a distant galaxy. It's completely invisible. Imagine a vast spherical shell made of icy objects, all surrounding our sun from an incredible distance. It's so far away that Voyager 1, the fastest spacecraft we've ever launched, won't even reach its inner edge for another 300 years, and it would take 30,000 years to cross it. So, if we've never seen it, how can we be so sure it's there? The answer comes from some of the most beautiful and enigmatic visitors to our night sky: comets. For centuries, astronomers were puzzled by comets that would appear seemingly out of nowhere, streak across the sky, and then disappear for thousands, or even millions, of years. Where were they coming from? In 1950, a Dutch astronomer named Jan Oort proposed a revolutionary idea. He suggested that these long-period comets weren't just random wanderers lost in space. Instead, they were messengers, kicked out of a giant, hidden reservoir of ice and rock located far beyond the orbit of Pluto. Think about that for a moment. A spherical cloud containing billions, perhaps even trillions, of icy bodies, some as large as mountains, all orbiting our sun from an unimaginable distance. This isn't just a collection of space rocks. It's a fundamental part of our solar system structure. It forms a kind of cosmic boundary, marking the very edge of the sun's gravitational influence. It's the line where our solar system ends and interstellar space begins. If you could somehow stand on one of these icy bodies in the Oort Cloud and look back, our brilliant, life-giving sun would appear as nothing more than a particularly bright star in the sky. But here's where the real mystery begins. We have never directly observed the Oort Cloud. Not with Hubble, not with the James Webb Space Telescope. It's simply too far away. Its objects are too small, too dark, and too spread out. It's like trying to spot a handful of charcoal briquettes scattered across a city from a satellite. So, why are scientists so confident it exists? The proof is in the orbits. When astronomers track the paths of these long-period comets, they find something remarkable. No matter which direction they come from, they all seem to originate from the same vast, spherical region of space, about 50,000 times farther from the sun than the Earth is. That consistent pattern is incredibly strong evidence. It's like finding footprints leading away from a specific spot in every direction. You know something must be there, even if you can't see it. The story of how the Oort Cloud got there is just as fascinating. The leading theory is that it's made of leftover material from the formation of our solar system, about 4.6 billion years ago. As the giant planets like Jupiter and Saturn grew, their immense gravity acted like a cosmic slingshot, flinging countless icy planetesimals out to the distant fringes of the solar system. There, they settled into stable, long-term orbits, forming this massive, spherical cloud. But there's another, more mind-bending possibility. Our sun wasn't born alone. It formed in a dense stellar nursery, a crowded cosmic city of young, new stars. Some scientists believe that during this chaotic period, our young solar system might have stolen icy bodies from its neighboring stars. If this is true, the Oort Cloud isn't just a relic of our own system's birth. It's a galactic melting pot, a collection of material from hundreds, maybe thousands, of different star systems. The comets visiting us today could be carrying ice that originally formed around a completely different star, billions of years ago. This invisible cloud doesn't just define our boundaries. It may have played a crucial role in our own existence. Comets are essentially giant, dirty snowballs, rich in water and organic compounds, the basic building blocks of life. It's widely believed that in the early days of our planet, a constant bombardment of comets delivered the water that now fills our oceans and the organic molecules that may have kick-started life itself. But this cosmic delivery service has a dark side. The Oort Cloud is also a source of potential destruction. Every now and then, a gravitational nudge perhaps, from a passing star or the tidal forces of the Milky Way galaxy itself, can dislodge a comet from its stable orbit and send it hurtling toward the inner solar system. Many scientists believe that the mass extinction events in Earth's history, including the one that wiped out the dinosaurs, could have been caused by impacts from these giant comets. In this sense, the Oort cloud is both the giver and the taker of life, a silent, powerful force shaping the destiny of our planet from the edge of the solar system. So, why call it a wall? Because for all practical purposes, it is the boundary of our home. It marks the limit of the sun's gravitational kingdom. Beyond the Oort cloud, you enter true interstellar space, a realm where the gravitational pull of other stars becomes stronger than our own. It's the final frontier of our solar system, a frozen, dark barrier separating us from the rest of the galaxy. And here's a final thought to really stretch your mind. Our nearest stellar neighbor, the Alpha Centauri system, is about 4.3 light-years away. If our Oort cloud extends 1.5 light-years in every direction, it means the outer edge of our solar system reaches more than a third of the way to the next star. It's very likely that our Oort cloud is brushing up against the Oort cloud of Alpha Centauri. The invisible walls of our star systems might actually be touching, their cometary clouds mingling in the darkness between stars. Imagine that, a shared, overlapping frontier where material from our solar system mixes with material from another. Until we can develop technology to send probes on journeys that will last tens of thousands of years, the Oort cloud will remain one of the greatest unsolved mysteries of our cosmic home. We'll continue to piece together its secrets from the ghostly trails of comets, build complex computer models, and dream of what lies hidden in that frozen darkness. The solar system is so much more than just the planets we know. It's a vast, layered, and complex structure, guarded at its edge by an invisible wall, silently protecting and threatening our tiny corner of the cosmos. Thank you so much for joining me on this journey to the edge of everything. If you enjoyed this deep dive into space, don't forget to hit that like button and subscribe for more cosmic mysteries. Let me know in the comments what you think is the most fascinating thing about the Oort cloud. Until next time, keep looking up.